We just ended with how to determine what type of chemical bond you have. We have 3 different types of chemical bonds: ionic, covalent, and metallic. You can review these on the previous video to figure out what they are. We're going to move forward and we're going to specifically look at ionic bonds. An ionic bond is going to be the attraction between positive and negative ions. Remember that a positive ion is what we call a cation, and a negative ion is what we call an anion. A couple of easy ways to remember which is which is for a cation, it actually has a plus sign in it, so that will help you remember that a cation is positive. An anion is a negative ion. One way that I remember that an anion is negative is that it's spelled similarly to onion. And when you cut an onion, it makes your eyes hurt and sometimes you cry, and that's a negative thing. So a negative ion is an anion. Another way to remember it is that it has an N in it for negative. Remember, if a cation is positive, that means that it has lost electrons, or it loses electrons. An anion is negative because it gains electrons. Okay, so those are your 2 different ions. And remember, for an ionic bond, we are transferring electrons, so therefore one atom will gain, the other will lose. Your ionic bonds are going to involve metals and nonmetals. The metal will be your cation. It loses electrons. Your nonmetal is the anion. It's going to gain electrons. Some of your ionic bonds will also involve a polyatomic ion. Again, here's this word, ion. Your polyatomic ions can be found on page 7 in your reference table. As I have already mentioned, in an ionic bond, electrons will be transferred. Metals give to nonmetals, so we are transferring from a metal to a nonmetal. Another thing about ionic compounds is that another name for them could be salts, and it doesn't have to be just sodium chloride. Any ionic compound is referred to as a salt. So like I said, for your ions are atoms with a charge. They can be positive or negative. They are formed by gaining or losing your valence electrons. So I should put in here valence electrons. They're the most important electron. They are the only ones involved in chemical bonding. Therefore, they're the only ones moving around. If we have a positively charged atom, that's because we have lost electrons, and we call that a cation, as I just mentioned. These are going to be your metals, anything on the left-hand side of the stair-step line on your periodic table. Your negatively charged ions are going to gain electrons. They are called an anion, and these are going to be your nonmetals. So your nonmetals will gain electrons until they have 8. We reviewed the octet rule in the previous video. Here is a picture of what I'm referring to. Here we have 2 Bohr models. We have one for sodium and one for chlorine. Here, sodium had one little lonely valence electron on its outer energy level. Chlorine had 7 valence electrons on its outer energy level. It only needs 1 more to have 8, which is perfect because sodium had 1 electron in its outer energy level. So what's going to happen? Sodium is going to donate or give its electron to chlorine. So now both atoms are happy and stable with 8 valence electrons on their outer energy level. Now, when we move electrons from one atom to another, we create charges, okay? These charges are here because of the movement of electrons. We have 1 less electron than we did before. We have one more electron than we did before. So we have our cation, which is sodium, and our anion, which is chlorine. Your periodic table can be very useful. It's going to be your best friend this semester in chemistry class. The periodic table can actually help you predict charges. This charge is what we call an oxidation number. Sometimes instead of oxidation number, you might see oxidation state, but they're the same thing. Okay, so I would jot that down. Oxidation number and oxidation state are relatively the same thing. They are arranged by group, and remember we're only talking about S block and P block elements, meaning groups 1 and 2, 13, 14, 15, 16, 17, and 18. We are skipping the transition metals charges for right now, and we will refer to them later. Your ions are going to combine, so the overall charge for the compound is 0, and I will show you what I mean soon. Alright, if you have your periodic table out, which you should pause this video immediately and write down how many valence electrons each group has, which is here in blue, and the oxidation state for each one of these groups. Alright, so pause the video and write these down at the top of your periodic table. Alright, so we are going to look at how the oxidation states and the valence electrons relate. Group 1, every element in group 1 has 1 valence electron. Remember, all atoms in these groups that we're talking about want to have 8 valence electrons. It does not make sense for any element in this group to go out and try to collect 7 more electrons. It's too much work. So this group here is going to give away its 1 extra electron to drop down in energy. When it does, it becomes a positive cation. Since we lost 1 electron, your charge will be a +1. For group 2, there are 2 valence electrons on the outer energy level. Again, it does not make sense for all of these elements to go out and try to get 6 more electrons. So instead, it is going to give away these 2 electrons and become a positive cation. A positive 2 cation to be exact. Skip the transition metals. Let's look at group 13. It has 3 valence electrons. It's going to give away those 3 electrons to have a positive charge here. If we look at group 15, group 15 has 5 valence electrons. It only needs 3 more to have 8. It will gain 3 more electrons to have a -3 charge. Group 16 has 6 valence electrons. It only needs 2 more to have 8. Therefore, it will have 2 extra electrons to create an anion with a negative charge of 2. Group 17 has 7 valence electrons. They only need 1 more to have 8. So they will collect 1 extra electron to create a negatively charged anion with a -1 charge. And then finally we have group 18, the noble gases. I like to call them the kings and queens of periodic tables. They don't react with anybody, but everyone wants to be like them. Fortunately for the noble gases, they already have 8 valence electrons. Therefore, they're not going to react with anybody because they're going to have a charge of 0. This slide just indicates, again, the number of valence electrons and the oxidation states for each group. If you'd like to take a minute to pause this video and write these down, feel free to do so, but I'm going to continue to the next slide. The next slide is going to show you how to use an electron dot diagram to show the transfer of electrons within an ionic bond. Here we have sodium and chlorine. Sodium is in group 1, so it will have 1 valence electron, and chlorine is in group 17, so it will have 7, which is a perfect combination. They fit perfectly together. Sodium will transfer its electron to chlorine, therefore creating an ion. Okay, so we'll have a sodium ion and a chlorine ion. Sodium will have a positive charge, and chlorine will have a negative charge. Remember earlier I said that we want the overall charge to equal 0. Well, if we have a positive 1 and a negative 1, the overall charge equals 0, and that's how we know we've done this electron dot diagram correctly. I would like for you to draw electron dot diagrams for the following compounds. We have potassium fluoride. You have 1 atom of each. You have magnesium oxide, 1 atom of each. And then you have magnesium chloride. Notice how there's this little 2 down here? That means you need to draw 2 chlorine atoms. Once you've drawn their electron dot diagrams, show the transfer of electrons to make sure that your nonmetals have 8 valence electrons. Take a minute to pause the video to do that. Some properties of ionic compounds. Ionic compounds are going to form a structure to what we call a crystal lattice. In a crystal lattice, it's going to be, some of them are cubed in shape, some of them are hexagonal. It just depends on what ion you're looking at or what compound you're looking at. But here your negative ions are going to alternate with positive ions, which is indicated here with different colors. So we have a blue circle and a red circle. Notice how they are alternating in color. That's because your positive atoms and your negative atoms are bonded together. If we want to break the crystal lattice, you have to have a minimum amount of energy called lattice energy. The last thing that we're going to talk about in this video are the strengths of ionic compounds based on their crystal structure. All ionic compounds, for the most part, are going to have high melting and boiling points, meaning that it's going to require a lot of energy to melt or boil your compound. They are also very brittle because they're in a crystalline structure. They will conduct electricity, but only if they are dissolved in water. That is the end of this video, and we will continue on in the next video.